Hello and welcome to my YouTube channel. Today in this fast track revision series, we will be learning about cardiac cycle. So first, let's look at the basics. The series or the cycle of events which occurs in a single heartbeat is called as cardiac cycle. So when we are saying single heartbeat, we are referring to the two heart sounds, lub and dub. The cardiac muscles of the heart contract and relax in a rhythmic cycle or in a repeating pattern. The contraction of the heart is called as systole and relaxation is called as diastole. And one cardiac cycle is composed of systole and diastole of atria plus systole and diastole of ventricles. The duration of cardiac cycle is of 0.8 seconds and in 1 minute there are 75 cycles, accounting for the 75 beats per minute. So now let's look at the events during a cardiac cycle. So let me turn on the pen first. So as you can see, the entire cycle is of 0.8 second. The first phase is atrial systole and it is of 0.1 second, the smallest phase of cardiac cycle. Then there is ventricular systole phase. This is of 0.3 second, and there is a joint diastole phase when both the atria and ventricle are in a state of relaxation. So this is of 0.4 seconds. So what happens during atrial systole? Let's go to this image. As you can see, this is right atrium, right ventricle and left ventricle. So during atrial systole, the blood is pushed into the ventricles from the atria. Both the atria pushes blood into the ventricles. Even before the atrial systole, ventricles are nearly 70% or 2/3 filled with the blood. So only 30% blood is pushed by the atria during atrial systole forcefully into the ventricles by opening the semilunar valves. So this happens during atrial cycle or atrial systole. Then as soon as the atrial systole ends, ventricular systole begins. So ventricles contract in two phases. The initial phase is referred as isovolumetric contraction, and during this the first heart sound is produced. And how this happens, let's see. So during isovolumetric contraction, since the ventricles are now filled with blood, so this blood filled ventricle pushes the atrioventricular valves here, leading to their closure. So this leads to the production of the first heart sound S1 lub, which is a soft low pitched sound of long duration, and during the late contraction of ventricles, semilunar valves, SL valves open, leading to the pushing of blood into the pulmonary trunk and into the aorta. So during the late ventricular contraction, semilunar valves open, leading to the flow of blood into pulmonary trunk, pulmonary artery and aorta. This phase is referred as ventricular ejection. Now once the contraction ends, it's the time for relaxation of the ventricles. So as soon as ventricle starts to relax, what happens? Let's see. Since the blood present in these vessels is in very high pressure, so it has a tendency to flow back towards the region of low pressure. So once the blood flows back, it closes the semilunar valves, leading to the production of second heart sound, that is dub. So dub is the second sound associated with the closure of pulmonary and aortic valves at the beginning of diastole and is referred as louder dub and it is of short duration. After the ventricles close, SL valves close, there is a brief interval when the ventricle blood volume does not change. There is a brief interval when the ventricle blood volume does not change because there is a very transient, very, I would say very, it exists for a very little time. There is a transient phase when all the valves, all the four valves are closed, and this is referred as isovolumetric relaxation because this is seen during the diastole phase. So at the beginning, this is referred as isovolumetric relaxation. Now ventricles are relaxing and meanwhile atria are also relaxing and the blood is getting filled inside the atria, and there is a point here, I can say, at the end of the diastole and at the beginning of the atrial systole. Means these two events are simultaneous. So when the ventricular pressure drops below the atrial pressure, since the atria are getting filled by blood while the ventricles are still empty, so when the ventricular pressure drops below the atrial pressure, the AV valves open, these valves open, and there is a gushing of blood from the atria to the ventricles, and during which the 70% of blood comes into the ventricles from atria. This is called as ventricular filling. This is called as ventricular filling. And during this time, there is third heart sound which is produced, and it is referred as ventricular gallop. So this is due to the hitting of blood into the ventricular valves. This is the third heart sound. And this event and atrial systole, they are so simultaneous that it is felt that atrial systole only pushes the entire blood into the ventricles. But now you know the case is slightly different. Now let's look at this awesome descriptive diagram which I got from Zain's blog. This is talking about the first phase of the cardiac cycle, atrial systole, means when the atria contract and a small amount of blood enters into the ventricle. As you have seen, this is of 0.1 seconds. Then there is a phase of isovolumetric contraction, which is a part of ventricular systole, means when all the valves are closed, ventricles undergo isometric contraction and pressure in the ventricle is increased. Why isometric or isovolumetric? Because the volume is not getting changed. Then there is a ejection period when the semilunar valves are opened and the ventricle contract and blood is ejected out. So this entire phase, or I can say these two phases, fall under ventricular systole, and the duration of this is 0.3 seconds. Now this is protodiastole. This is the first stage of diastole, means just at the beginning of the diastole, protodiastole is seen. The semilunar valves are closed at the end of this period, and due to the closure of semilunar valves, you can hear the second heart sound, that is dub. And then there is a phase of isometric relaxation. When all the valves are closed, ventricles undergo isometric relaxation and pressure in the ventricles is reduced. And then you have seen the phase of rapid and slow filling. Atrioventricular valves are open at this time and ventricles relax and filling occurs. And all of these phases, they are the part of joint diastole, which is of 0.4 second. But if you will observe this diagram closely, you will see the contraction of atria ends here, means at this, when the ventricular contraction begins. So atria relax for a longer time than the ventricles. And let's move to the next slide, which is talking about the timings of cardiac cycle, which we have already discussed. So let's see in a little pace. Atrial systole, where the atria contract and eject blood into the ventricles, it lasts for about 0.1 second. Then ventricular systole lasts for about 0.3 seconds. Atria and ventricular diastole, where the blood from large vein flows into the atria and ventricles, and it lasts about 0.4 seconds. The atria are continuously relaxed and filling with the blood from the veins for all but 0.1, except for 0.1 second of the atrial systole contraction. Atria is in relaxed phase, means the relaxation time of atria is 0.7 seconds. So atria is relaxing nearly for the longest time. As you can see, atria is relaxing From this, as soon as the contraction ends, atria is relapsing up to here. So it is of longest phase, and as we have seen, S1 comes here, which is the love, and S2 comes here. So if somebody questions you that what is the duration or the time period between lub and dub, so you can say the time period between lub and dub is 0.3 seconds. And what is the time period between dub and lub? So it is 0.4 plus 0.1. So this is 0.5 seconds. Between dub and lub it's 0.5 seconds, and between lub and dub it's 0.3 seconds. So now let's see some of the important parameters. Ventricles are about 70%, as I have discussed, filled with the blood, about 105 ml even before atrial systole. Atrial systole contributes about 25 ml of blood to volume already in each ventricle. So at the end of atrial systole is the end of ventricular diastole. As we have seen, as the ventricular atrial systole ends, ventricular systole begins. So thus each ventricle contains about 130 ml of blood, means 25 ml is contributed by atrial systole and 105 ml is already there in the ventricles. Thus each ventricle contains about 130 ml of blood at the end of diastole, called as end diastolic volume. This is very important parameter. Now next is the left ventricle ejects about 70 ml of blood into the aorta, and right ventricle ejects the same amount of blood into the pulmonary trunk. The volume remaining in each ventricle at the end of systole after contraction, the volume remaining in each ventricle is 60 ml, and this is referred as end diastolic volume. Now we will look at very important parameter that is very common in NEET, that is cardiac output. So cardiac output is the volume of blood pumped per minute by each ventricle. So as we know that heart performs 72 to 75 cardiac cycles per minute, that's what is given in the NCERT. So that is equal to the number of heartbeats. So during cardiac cycle, each ventricle pumps about 70 ml of blood per minute. As we have seen here, each ventricle pumps about 70 ml of blood into the aorta and the pulmonary trunk. And this volume is referred as stroke volume. So when the stroke volume, that is 70 ml blood per beat, is multiplied by the heart rate, which is 72 beats per minute, then we get cardiac output which is nearly equal to the 5 liters per minute. So 5 liter is the amount of blood that passes through the heart per minute. Body has the ability to alter all of these parameters. When I say all of these, I am referring to stroke volume, heart rate, as well as the cardiac output. As seen in case of athletes, they have a better cardiac output. And then as I have said, there is a third heart sound, also referred as ventricular gallop. So it occurs just after the second heart sound. Mitral valves open, allowing the passive filling of the left ventricle, during which the 70% of the ventricles get filled. So far you have been studying that heart beat is like 72 to 75 per minute, but it has a range. So for adults it's between 60 to 100 beats per minute, and for children the count of heartbeat is 120 to 160 beats per minute. So if you like the content, please like, share and subscribe, and stay tuned for the next video. Thank you.